Hello class, welcome to chapter 7. Chapter 7 for um, the trick we have, let me see, we have the summary of chapter 7 and you will learn about a lot of size, a lot of cosize, and we will learn about the area of the triangle by using the formula. Plus, we are having we are having some example. Like, I think here, I remember in the homework they have like some problem relate a lot to lot of cosine and lot of size. So I will mainly focus on those, and I will show you how to use those to apply to your in your homework. Look like right here a lot of size, and you notice we are having any triangle doesn't have to be right, any triangle ABC. So we have three sides, right? Small size A is literally the opposite of angle A, and side B, small b, and C. A lot of size, this always true. So most of the time they will given us one side of an angle and a sine. And we do have like or sometimes they give you um, side of the other angle and missing one of the sides. So your job will have to figure out the rest. So in order to do this, you notice that we are having side of A, which is this side of angle A, over the opposite, which is small side A, right? Equal to side of angle B divided by the opposite of that angle B, which is small side B, and same as side C, divided by C. So this all will be equal. So this means, let me get my pen. Okay, let me annotate on here on the picture for you. It means most of the time when you want to solve for something, all the time, take at least two pairs, okay? So they might given us side of A and side of B. And small a, for example, they want you to find B. In order to do this, you want to do cross multiplications, for example, like this. See? This with that and that, side B with A. So which means you're going to have side A times B equal side of B times small a. And then to find side B, as I just mentioned, like if you want to find side B, you divide both sides by side A. So which means B will be equal to side B given, right, time A divided by side of A. And you have the solution for side B, small b. Similar, so if they given you this pair, you do the same thing. Or even if they given you side A divided by small a, that's they given, equal to side C, but they're not given small c, you do the same thing. So you only need to choose two pairs to any other pairs. But remember, you have to, remember this kind of the way that they're setting up this triangle, okay? So that you can apply correctly, see? And that would be equivalent to small a divided by side A, which means once you flip over one of the side, you have to flip all of it, which means small a divided by side A equals small b divided by side B equal to small c divided by side C. So you can pick these two pair to do it. If they given you three of it, then your job, you have to figure out the other. It's just similar to the top problem. So the example on the left, they given us angle A is 30, angle B is 70, and small side A is 8 centimeters in a triangle ABC. Doesn't have to be right. Then by the law of size, you apply, then you're gonna have this formula, like I just figured out, right? And then you plug in all the value, and then you got the value. Remember, when they're asking for the sign, remember to provide unit if they have units at first. So that is, example number 2, they given you side A, small b, and angle A, right? Again, for this one, like I said, you can apply, we call cross multiply, or you say proportion method, or cross multiply, you do the same thing to figure it out, all right? So that's very simple. Just focus on the formula, then you'll be fine. Law of cosine is a bit different. For law of cosine, for any triangle ABC, okay, so they set up the same, the same picture. So the following relationship will be true, which means you don't have to apply all of these 3 on your work. You can choose depend on what they're asking. For example, they want to ask like they provide you side B, side C, and then angle A. They want you to find side A. Then you want to use formula 1. Okay. This is formula 2, and this is formula 3. They are equivalent. Okay, it just depends on what they're asking you. Then you would choose to take that formula to apply. All right. So remember, so the way to remember this, for example, we have a squared equal to b squared plus c squared. So, and minus 2 times b times c, right, which is given, times cosine of angle A. So usually they will provide you angle A, then you're using cos on a lot of cosine to figure it out, which is this. So the example would be on the right side, the left side. We have side A, side B, side C. We have everything. So what do they ask? Then we can find A using the law of cosines. So which means they provide all of the side for us except this, right? So except the angle A. In order to find angle A, you must find cosine A first, and then using inverse function to find angle A. So what do they have? So you still write all of it. So you can apply either 3 of this, but here you can apply the first one. So if you apply the first one, then we're gonna have, you have to move everything away from cosine A first. Move that away. And then by what? This is plus and minus, all right? B squared plus C squared, and then minus. So do the, using addition and subtraction to move B squared and C squared away first. And then from there, we're gonna have, so in the textbook doesn't like give you specific, but I would show you steps. So for A squared equal to B squared plus C squared minus 2BC times cosine A, I'm gonna minus B squared and C squared for both sides. Then I'm gonna have A squared minus B squared minus C squared equal to minus 2BC times cosine of A, right? So now our job we have to find cosine of A. In order to do this, you see that here, -2 times B times C, they are multiplications. So in order to remove that, we have to divide. I use red, so you divide both sides by minus 2BC. Divide minus 2BC. Okay, so if we're going to use this formula, then we're going to have next. You can leave it at this and plug in the value to find cosine A. So here on the right side, this means cancel, right? So on the right side, we only have cosine A only. The left side, we have A squared minus B squared minus C squared divided by minus 2BC. So you can leave it like this and plug in the value. But if you want to be exactly from the formula like this, what do you need to do? So here they factor out minus sign on the top. If they factor out minus sign on the top, then we're going to have what? They factor out minus 1. Okay, so we have minus a squared plus b squared plus c squared. Parentheses minus in the front. Divided by the bottom will be minus 2bc, still the same. So now what do they do next? So this will be cosine A, right? So what do they do next? They're going to cancel, because here is look like the multiplication. You're going to cancel the minus sign, cancel it. So you're going to have this, and then you can rearrange the place. You have b squared plus c squared minus a squared divided by 2bc equal to cosine A. So that would be exactly the formula that they provide. But like I said, you don't have to. And then you plug in all the value, but make sure. So make sure when you are plugging all the value, be careful with the square, okay? Even be careful with the minus. So over here is mean. I would like to explain over here. That means we have minus a value, and whatever b values in here, you square it. You're not gonna square the negative sign, okay? And even minus a squared like this too. You're not gonna square a negative sign. No, you square the negative sign when they give you the parentheses like this, then you square the negative b, okay? So be careful. Let me erase that. Okay, so when you plug in, you got a value. You got a value cosine A equal to minus 0.6. So you're gonna use calculator, okay? You're gonna press in inverse cosine with the degree, then you're gonna have the value 126.9 degree. Okay, so that's how you do it all the time. When you're finding just the angle, you have to use the inverse function. All right, and in a textbook, they might have direct formula like this. Let me erase over here. We call alternate formula. So this is the official formula. So we have the other alternate formula, which is like this. For example, from formula 1, and I'm gonna have let's say the alternate. Okay, so let me copy down from the textbook. We have cosine of A equal to b squared plus c squared minus a squared divided by 2bc. You can apply this all the time. Every time that they're asking for angle A, then you using this formula. Number 2, we have cosine B, which means you have a squared plus c squared minus b squared. Everything divided by 2ac. Third formula, cosine C will be equal to a squared plus b squared minus c squared divided by 2ab. Okay, and remember to all the time when you find asking for a specific angle A or angle B or angle C, you must use inverse cosine. Okay, and you got a solution. That's all. So these are important formula for you to apply to find size or angle for any triangle. That's the purpose. All right, so let's watch some video. Oh, for the area, you just like apply to plug in value, and that's it. It's not hard. Usually they will provide you every single details. Your job just figure out what is A, what is B, what is angle C. Then you apply psi into this, and then using the formula like S equal to 1/2 times A times B times psi of C, and so on. You notice here we have 3 formula, right? And you also have the area of the triangle in which we are given all 3 sides, and you have this formula. If they're given you all 3 sides, then you want to apply that. Remember, small s and big S different. Big S represent for the area of the triangle in this case. And the small s in here, okay, will be equal to 1/2 time parentheses a plus b plus c. Okay, and we have some other formula as below right here, like this. We have three alternative formula. We have s equal to a squared times sine b times sine of c divided by 2 times sine of a. If they provide you all three angles, then you are using this. If not, then just, you can print it out. If on the test have this question, you can print this all out and then look at the formulas. I don't mind. All right, so let's watch the video together. We are having video for chapter 7, 4 section. Have this.
We're going to start our work now with solving triangles, and in this lesson we're going to work with what's called the law of sines. The triangles we're going to work with in this section are not necessarily right triangles. So let's look at our first example. We have triangle ABC, which is not necessarily a right triangle, in which angle A is 50 degrees, angle B is 60 degrees, and side A is 36 kilometers. We want to find the measure of angle C, and then we want to find the measure of side C. So I'm going to start this problem by drawing a triangle. Doesn't have to be very accurate. Just going to use it to label the information that I'm given. Here's angle A, angle B, and angle C. I know that angle A is 50 degrees, so I'm going to label this angle with 50 degrees. Angle B is 60 degrees, so I'm going to label that 60 degrees. And then side A is 36 kilometers, so I'll label this with 36. Now, I have my triangle right here for reference, and I've labeled the information that I'm given. And now I'll look and see if I can find angle A first, and then after that, I'm going to find side C. So let's start with angle C. And this is what I have. C will be 180 degrees, subtract the sum of 50 degrees and 60 degrees. That's because the sum of the three angles in any triangle have to add up to 180 degrees. So I have two of them, 50 and 60. I'll add those up, subtract from 180, and I'll have the measure of angle C. So 50 plus 60 is 110. 180 subtract 110 is going to be 70 degrees. So angle C is 70 degrees, and so I'll label my triangle over here with 70 degrees for angle C. Now the next thing I want to do is find side C, the length of side C, so that's right over here, opposite angle C, and to do that I'm going to use my law of sines. So let's do that next. So what I'm going to say is this: C is to the sine of the angle opposite, which is angle C. So C is to sine 70 as, I'll take this ratio right here, 36 is to the sine of 50. 36 is to the sine of 50 degrees. Now that is what we call the law of sines. And the law of sines says that the ratio of any side to the sine of the angle opposite is constant in any triangle. So C is to the sine of C as A is to the sine of A. So I have this ratio filled in right here with three of the things known and one unknown. It's very easy to solve for the unknown. I'll multiply both sides by the sine of 70, and so I'll get C is equal to 36 sine 70 degrees, all divided by the sine of 50 degrees. Now, if I do this on a calculator, which I've already done, I'll just show you the first few digits here. It's going to be 36 times 0.9397. That's the first four digits of what I get if I find the sine of 70 degrees on my calculator, divided by sine 50 on the calculator is going to be 0.7660. I do the arithmetic on my calculator, round off using my significant digits here. I get 44 kilometers for the length of side C. So I use my law of sines by setting up these two ratios. C is to the sine of 70 as 36 is to the sine of 50. Then I use a calculator, work all this out. I end up with C is equal to 44 kilometers. So I've succeeded in finding angle C and then the side opposite that. Let's look at another problem. We have triangle ABC with angle B is 13.4 degrees, angle C is 24.8 degrees, side A is 315 centimeters, and we want to find all the missing parts. So again, I'm going to draw a triangle here for reference. Doesn't have to be accurate. I'll label it A, B, and C. Now, angle B is 13.4 degrees, so I'll put 13.4 degrees right here. Angle C is 24.8, so I'll put 24.8 degrees here. And then side A is 315 centimeters, so I'll put 315 right here. So I need to find angle A, I need to find side B, and I need to find side C. So I'm going to start by finding angle A. So angle A will be 180 degrees, subtract 13.4 degrees plus 24.8 degrees. Do that on my calculator, and angle A comes out to be 141.8 degrees. So that's angle A. I'll fill in my triangle right here with 141.8 degrees. So you can see right away that I haven't drawn a very accurate triangle right here because this is an obtuse angle and of 141.8 degrees, and the triangle certainly doesn't look like that. But that's okay for our purposes right here. We're using this triangle just so we can take a look at what's given to us and what we're asked to find. Now I'm going to use the law of sines next to find the measure of side C, and I'm going to say this. The length of side C is to the sine of 24.8 as 315 is to the sine of 141.8. That's the law of sines. Here we go. C is to the sine of 24.8 degrees as 315 is to the sine of 141.8 degrees. I'll multiply both sides by sine 24.8 degrees, and I'll end up with C is equal to 315 sine 24.8 degrees, all divided by the sine of 141.8 degrees. Now, I've worked this out on a calculator, and I've done that already, and that comes out to be, to three significant digits, 214 centimeters. So 214 centimeters for the length of side C. So if I go up to my original triangle right here, I can label this as 214 centimeters for the length of my side C right here. The only thing left to find now is side B, and I'll use the law of sines again to say that B is to the sine of 13.4 as 315 is to the sine of 141.8. So let's do that problem over here. And I'll say B is to the sine of 13.4 degrees as 315 is to the sine of 141.8 degrees. And multiply by sine 13.4 degrees both sides, and I end up with B is equal to 315 sine 13.4 degrees, all divided by the sine of 141.8 degrees. I worked this out on the calculator, and again, I've already done this, and I get 118 centimeters for the length of side B. So the law of sines, as you can see, is a very valuable tool in solving triangles.
Okay, so that's section 7.1. Let me see if I'm recording. Okay. If you have any question, please, for this type of problem, like just be careful what they given and plug in. And if you still have question, please ask me. We have the next video 7.2.
In this lesson, we continue our work with the law of sines to cover what's called the ambiguous case. Here's our first example. We want to solve triangle ABC if angle A is 30, side B is 40 feet, and side A is 10 feet. Okay, we're going to draw a little reference triangle that we can label A, B, and C. Okay, angle A is 30 degrees. Side A is 10. That's this right here. And then side B turns out to be 40 feet. Okay, so according to the law of sines, then, the only thing that I can solve for first here would be angle B. And what I'll say is that the sine of B is to 40 as the sine of 30 is to 10. So let's do that next. So the sine of B, the sine of B is to 40 as the sine of 30 degrees is to 10. So this is the law of sines, just like I used in the previous section, except here I'm saying the sine of an angle is to the length of the side opposite as the sine of some other angle is the length of the side opposite it. So it looks just like the same ratios that we used in the previous section, it's just that they're upside down in this case. Let's solve for sine B. I end up with sine B is equal to, I'll multiply both sides by 40, and so I have 40 sine 30, all divided by 10. So sine B comes out to be, let's see, sine 30 degrees is just 1/2 times 40 is 20, divided by 10 turns out to be 2. So I end up with sine B is equal to 2. Now, if you put this into your calculator, press your inverse sine button, you're going to get an error because there is no angle whose sine is equal to 2. The sine of an angle is always between -1 and +1, so it's impossible that this can happen right here. So there's no angle that fits this description, which means that there's no triangle that fits this description. And here's what's wrong. This side B, this side A right here of 10 is so small compared to this angle and this side that no matter where I put it, like this, I can never reach this side right here. So no triangle fits this description. So this is one case of the ambiguous case in which the given information yields no triangle. Let's try another example. This time angle A is 120 degrees, side B is 20 centimeters, and side A is 30 centimeters. Let's see what happens on this triangle. Now here I have an obtuse angle right here, so I'm going to draw my triangle in a little bit more detail. Since I know that angle A is an obtuse angle of 120 degrees, I'll draw my triangle like this. So there's 120, here's angle B, here's angle C. Side A is 30, that's opposite angle A, so I'll make that 30. Side B is 20 centimeters, it's opposite angle B, so I'll make that 20. And I'll look here and see what can I solve for first. Again, the only possibility is with the law of sines is for solving for angle B. So I'm going to say the sine of B is to the length of the side opposite, which is 20, as the sine of angle A, sine of 120, is to the angle opposite, is to the side length of the side opposite, 30. So sine B is to 20 as sine A is to 30. That's my law of sines. I'll multiply both sides by 20, and I'll end up with sine B is equal to 20 sine 120, all divided by 30. Now I work this out on the calculator, and this comes out to be 0.5774. So I have sine B is equal to 0.5774. Use my inverse sine button on my calculator, and this tells me that angle B, and let's see, I'm going to round to the nearest degree right here. Angle B is 35 degrees. Or I also have to include this possibility, B prime is 180 minus 35, which comes out to be 145 degrees. Now I have to include this possibility right here because sine B equal 0.5774 and angle B is an angle in a triangle, it has the possibility it could be an angle between 90 and 180 degrees. Both 145 degrees and 35 degrees have a sine of 0.5774. So when I'm solving a triangle like this, I have to include these two possibilities right here. Now, in this case, B prime equal 145 degrees doesn't make any sense because I already have an angle of 120 degrees. Another angle of 145 degrees is impossible because their sum would be bigger than 180 degrees. I have to include the possibility myself to begin with, but then I look and see that it conflicts with what I already know about the triangle. So in this case, I have one triangle that fits this description, and in that triangle, angle B is 35 degrees. So let's look at one more example. In this triangle, angle A is 38 degrees, side A is 41 feet, and side B is 54 feet. Now, I've drawn the triangle over here for reference myself already to save a little bit of time. You can see that I have angle A, the side opposite angle A. I have side B, so I can solve for angle B to start with. So the sine of angle B is 254 as the sine of 38 degrees is 241. Now, I'll multiply both sides by 54, and I'll end up with sine B is equal to 54 sine 38 degrees divided by 41. I've worked this out on my calculator, and sine B comes out to be 0.8109. From my calculator then, I know that angle B could be, using the inverse sine button, 54 degrees. But I also know myself that angle B could have a second value, so I'll call that B prime, 180 degrees minus 54 degrees, which is 126 degrees. So again, I have to include this possibility myself. Sine B comes out to be 0.8109. I know B is an angle in a triangle, so it has to be between 0 and 180 degrees. Well, my calculator gives me this value when I use the inverse sine button, 54 degrees. Then I have to include this value myself, the angle whose reference angle is 54 degrees. So 180 minus 54 degrees is 126. Now just check and see if this is a possibility. 126 degrees and 38 degrees, that's less than 180 degrees. So I do have two triangles that fit this description. In one of the triangles, angle B is 54 degrees. And in the other triangle, B is 126 degrees. And that's what I get if I draw this side this way, where that angle is 126 degrees. So you can see, here is my two triangles. One, the blue one that I drew in originally, where angle B is 54 degrees, and then this other triangle over here where angle B prime is 126. Notice that the length of this line is still 41. This line and this line have the same length, so angle A is 38, side A is 41, side B is 54, and angle B is 126. All the given information stays just like it was. So with the ambiguous case, you have the possibility of no triangles, like we saw in example 1. One triangle fits the description, like we saw in example 2, or this case where two different triangles fit the given information that we started with. So that's called the ambiguous case, and you get 0, 1, or 2 triangles.
All right, and we will have the next section, law of cosines.
In this section, we use the law of cosines to solve for the missing parts in some triangles. For our first problem, we have solve triangle ABC if side A is 410 meters, side C is 340 meters, and angle B is 151.5 degrees. So you can see I've drawn a little picture right here of the situation. Angle B is included between sides A and side C. So I can use the law of cosines here to solve for side B. And here's the law of cosines. B squared is equal to A squared plus C squared minus 2AC cosine of angle B. So according to the law of cosines, this is going to be the formula I'm going to use. Whatever side I have over here, it's the other two sides right here. And then the angle that goes here is the angle that's opposite this side. So let's fill in these numbers for this situation. So I have a squared, which is going to be 410 squared plus 340 squared minus 2 times 410 times 340 times cosine of 151.5 degrees. Now I've worked that out on the calculator. On the calculator, that comes out to be b squared equals 528,714. That's b squared. Now I take the square root of that to get b, and rounding to 3 significant digits, I get 727 meters. So that's side B, 727 meters using the law of cosines. So I use the law of cosines to solve for side B. Now I have side B, the angle opposite. I can solve for either one of these two angles right here. Since I have a choice of which angles to solve for using the law of sines, let's use the law of sines to solve for angle C first. So using the law of sines, I'm going to have sine C, which is what I'm looking for, is to side C, 340, as the sine of 151.5 degrees is to 727. So I set up my law of sines that way, solve for sine C, and I won't show you the work right here. I put this on the calculator and get approximately 0.2232. Using my inverse sine button on the calculator, that tells me that angle C must be equal to 12.9 degrees. So 12.9 degrees. I don't have to check for an angle C prime like I would in the ambiguous case, because I already have an angle in this triangle that's bigger than 90 degrees. So I'm not going to have another obtuse angle, so there's no need to say 180 minus 12.9 degrees. This is angle C. So angle C is equal to that. Last thing I have to do is find angle, what is it, A? And angle A will be 180 degrees minus 151.5 degrees plus my 12.9 degrees. And I've already worked that out also, and that comes out to be 15.6. That's angle A. So law of cosines first, because I have an angle and the two sides included on either side of the angle. And so I use my law of cosines to find the side opposite that. Then I switch over to the law of sines to find my next angle. Once I have that, I just subtract the two angles I already have from 180 degrees, and I have my third angle. And that triangle then is solved completely. Let's go to our next problem. If A is 38 meters, B is 10 meters, and C is 31 meters, let's find the largest angle. Well, let's draw a little picture right here just to help us out. We have A, B, and C for my angles. Let's see, I'll label side A with 38. I'll label side B with 10, and I'll label side C with 31. Now, when I look at my diagram right here, I know that the largest angle is opposite the longest side. So I see my longest side is 38, so my largest angle is going to be angle A. And remember, this is not drawn to scale. I've just drawn this triangle so I have something to label. So I'm going to solve for angle A first using the law of cosines, and the law of cosines tells me this. Cosine of angle A will be B squared plus C squared minus A squared, all divided by 2BC. So according to the law of cosines, I can write the law of cosines that way to solve for angle A. Let's substitute in now, and I'll have, let's see, 10 squared plus 31 squared minus 38 squared, all divided by 2 times 10 times 31. I've worked that out on the calculator. That comes out to be negative 0.6177, negative 0.6177. That implies that when I use my inverse cosine button on my calculator, that angle, whoops, not B, but angle A, comes out to be 128 degrees. So pretty simple, using the law of cosines to find the largest angle in this triangle. It's going to be opposite the longest side. Here's my law of cosines, that formula for cosine of A. Substitute in these values, get out this decimal right here, inverse cosine button on the calculator. A is equal to 128 degrees, rounded to the nearest degree, so I have my significant figures right here. That's a look at the law of cosines.
All right, we do have so law of cosine. The last section is the area of the triangle.
Next, we have some formulas that allow us to find the area of a triangle in different situations. Let's look at our first one. Want to find the area of triangle ABC if side A is 41.5, side C is 34.5, and angle B is 151.5. Now, if we draw a triangle and label all the information that we're given, it looks like this. And what you can see is that I have this angle and the two sides that are adjacent to it. So what I have is a situation that we can call side, angle, side. So two sides and the angle included between them. Two sides and the angle included between them. In that situation, we use this formula to find the area of the triangle. The area is going to be 1/2 the product of the two sides times the sine of the angle between them. So I'll simply substitute in the numbers I'm given. Side A is 41.5. Side C is 34.5. And then I have the sine of 151.5 degrees. Work that out on the calculator. That comes out to be 342. And my units were meters, so it's going to be square meters. So the area of that triangle is 342 square meters. I look at the situation right here. I find out it's a side angle side situation. I know that's going to refer to this formula right here. 1/2 the product of the two sides times the sine of the angle between them. The formula and the area of that triangle just falls right out. Let's look at our next problem. This time, angle A is 46 degrees, B is 95 degrees, and side C is 6.8 meters. So here again, I've drawn a little triangle. I've labeled all the information that we're given. And you can see in this case, I have two angles and the side included between them. So this is a situation which we will call angle, side, angle. And in this situation, angle, side, angle, we use this formula to find the area of the triangle. The side squared times the product of the sine of the two angles divided by 2 times the sine of the third angle. Let's substitute in and see what we get. So it's going to be c squared, so 6.8 quantity squared, sine of 46 degrees, sine of 95 degrees, divided by 2 times the sine of, okay, this will be angle C. Up here, I'll have to find that. That'll be 180 degrees minus 46 degrees plus 95 degrees. That's going to come out to be 180 minus, let's see, comes out 39 degrees. Okay, I substitute these numbers into my calculator, do the arithmetic. I end up with 26.3. Again, my units are meters, so it's 26.3 square meters. And that's the area of that triangle. So this situation is angle, side, angle, because I have two angles and the side included between them. In that situation, I use a formula that looks like this. Simply substitute in, have to do a little arithmetic here to find out the measure of angle C, but that's easy. It's just 180 minus the sum of those two angles. That comes out 39 degrees. The rest of it's just done on the calculator, and there we have that. One more formula we want to use in which we're given the 3 sides of a triangle. Here are the 3 sides. A equals 4.8 yards, B is 6.3 yards, C is 7.5 yards. Here's my triangle that I've labeled with this information. And you can see that this is a situation that we call side, side, side. The formula for the area of this triangle is big S equals the square root of little s times the quantity little s minus A, little s minus B, little s minus C, where little s is 1/2 the perimeter of the triangle. So I have to calculate that first. Little s is 1/2 of 6.3. plus 7.5 plus 4.8. I do that arithmetic, 1/2 of that sum turns out to be 9.3. So that's 1/2 the perimeter. Now I can substitute that into this formula and get big S is equal to the square root of 9.3 times 9.3 minus 4.8. 9.3 minus 6.3, and then 9.3 minus 7.5, all that square root. So I have half the perimeter times that number minus one side, that number minus the next side, that number minus the third side. So it's a real simple formula. Once you have half the perimeter, I substitute in for those numbers and I end up with, rounding off, 15 square yards. So if I do all this on the calculator, work it all out, I end up with 15 square yards. So real easy to find the area of a triangle in which we're given all three sides using this formula. First, I find the number that's half the perimeter. Then I substitute into this formula, half the perimeter times that minus the first side, that minus the second side, that minus the third side, form that product, find whatever that product is, take the square root, what drops out is the area of that triangle. So there's a look at finding the area of a triangle in three different situations using three different formulas.
All right, class. And remember, when you are finding the area, so you have to give me unit or finding sign. You must give me unit to get full credit, okay? All right, class. So we are finished chapter 7. I tried, even chapter 8 is not on the test. However, if you want to look ahead of the mini lecture, so please go to XYZ and then do like me. Then you will see the mini lectures. If I have time, I will go over it and post it. Okay? Okay, class. Thank you very much.